continue the example we are talking about on backward propagation algorithm. And so the aim of the backward propagation is to distribute the error in the back part of the network in such a way so to update the weights, and so that when the next forward propagation loop works, it uses the new weights and tries to reduce the error. And when we see the difference between this error and the next error after the updated weights, we'll see that the total error will be reduced by certain margin. That means we are kind of zeroing towards the minimum weight. Okay, so that's the objective of the backward propagation. This loop can happen many times. Okay, so now just to explain this, when I said that we want to distribute this to the network, we have to check that how the weights, all these weights can be adjusted to reduce the total weight. So how E total, that is the total error, is affected by changing the weights. Let's say this weight, okay, W11 prime, which is the first one, right after this output neuron. Okay, so here I changed some nomenclature, like the output one, we call it Y out. This is basically this thing, the activation function, the output of the activation function, and Y in is the summation of the previous weight. Okay, so you can see that the total weight is basically dependent on the outcome of the output neuron, which is basically dependent on the Y1 in, which is the input of the output neuron, and which is again dependent on this weight. Okay, so this is like a multi-step dependence. This one you have to understand. So E total is dependent on Y1 out. Okay, Y1 out is dependent on Y1 in, which is the input, like this thing, and that is dependent on this, which is like W11 prime. That means the output of the first neuron of the hidden layer. You see this, that shows that when we try to calculate how E total is being affected by a change in W prime 11, we have to see that what is the slope of this del E tot divided by del W prime 11. That will be our slope. That will be this thing when we want to calculate the new value of the weight. But we cannot calculate the weight of del E tot, which is this thing. Let's say this one, that del E tot divided by del W prime 11. This is the slope. This slope we need to calculate, but we cannot calculate this slope directly because this is a multiple dependencies there. We can do it only using the chain rule in calculus. Okay, when y equal to f of u and u equal to g of x, then if we want to calculate dy dx, so we have to use that dependency. Dy dx equal to nothing but dy du. Take a derivative with respect to u, and then du dx. Okay, so we take derivative of u with respect to x and then multiply them to get the dy dx. Exactly that way we do this. Okay, del E tot divided by del W11 prime equal to nothing but del E tot divided by del Y1 out, then del Y1 out divided by del Y1 in, and then del Y1 in divided by del W prime 11. Okay, so the whole thing we need to calculate. Now we separately calculated this one, three of them we separately calculated. The calculation will be I'll be sharing a web page where they have done the calculation, but this is the very simplified form. If we take the derivatives, if you know the very basic calculus, you'll find out that this outcome of this will be Y1 out minus the expected value of Y1. Okay, this expected output of Y1 is 0.05. The second one, which is nothing but the derivative is nothing but the derivative of the error function. If you remember, sum of half times expected minus actual whole square. This one, del Y1 what is nothing but the the derivative of the activation function, is the sigmoid function, and the activation function's derivative is Y1 out times 1 minus Y1 out. Okay, and the third one is del Y1 in divided by del W prime 11. This is this input. Okay, so the input, how we calculate? We calculate using H1 So this is nothing but the output of this function times w prime 1 1, and then output of this functions times w prime 2 1. So that is the, and when we take derivative of it, we find the output of this function, this one. So that is the output. Now if we calculate the whole thing, we just have to multiply this and this and this. Okay, so we did that exactly, multiply the whole thing, and we got this del E tot divided by del W11 prime, which is nothing but the slope of that equation. Now we need a learning rate, and then we subtract this thing from the old value of W prime 1 1. So you see exactly that thing we did. The new value of W prime 1 1 is nothing but the old value of W prime 1 1 minus the learning rate times the slope, okay, which we calculated here. Okay, so now if the learning rate is 0.6, we put the values here and find out the new value of W prime 1 1 is 0.45187, which is the new value for this one. Okay, and similarly we can calculate the new values for W prime 1 2, W prime 2 1, W prime 2 2, and then we will also come before the hidden layer and calculate W11, W12 and all other. And then next time when we do the forward propagation, we'll use the new weights and then see whether the error has actually reduced using the new weights or not. And this is way, if we keep taking multiple iterations, we'll finally go to that the expected error zone.